So that means that a squared is e. But that's a contradiction because a squared is supposed to be, a squared is distinct from this. Right? These are all different. So you can't have a squared equal to e. That's a contradiction. Therefore, go back and negate what you negated at the beginning. So you negate this. Hold on. We assume the equality. So you negate the equality. Therefore, AB cannot be equal to BA squared. Right? So we've now eliminated how many? 1, 2, 3, 4, 5, and 6. We've eliminated 6. We're talking G8, so there are two remaining possible values left. Right? Which are what? Well, if you cross out all the ones we've shown impossible, you're left with two possibilities. BA, you're left with this one, and BA cubed. Right? So either that one or that one. Okay, that was case 1 when b squared is e, and case 2 was when b squared is a squared. But now we've got two sub-cases. Right? So we need to. So we're going to split, the branching splits again. So for case 1, we've got now two sub-cases. So case 1.1, 1.2. Okay, so for the case when b squared is e, AB, we have two possibilities. AB is either BA or AB is BA cubed. So let's do this one now. So this is case 1.1. So AB is BA. That's commutation. So if that's true, for any A or B, then your group is abelian, right? And now that we know this and we know that, we can actually construct the group table. And when you do that, so you can construct the group table, and here it is done. And again, you'll probably have to do some algebra to get the values of your group table in this form. All right. Now, this group table is the group table of C4 times C2, another direct product. Okay. So when you have b squared is e and AB equals BA, you plug in all those values into your group table, and do the appropriate algebra to get into the form of having the B on the left each time, right? Then this group table is isomorphic to C4 times C2, right? So we have another case. We have our, what's that, the third case. We've got the cyclic case. We've got C2 by C2 by C2, and now we have C4 by C2. Now the presentation of this group, this third type, remember the relations, that you have a set of relations and you'll have a set of generators. Generators obviously A and B, because here are all the elements of your group, and you have generated them with just two generators, A and B. Yeah, that's obvious. Right? You've been able to generate all members. Okay, so the generators are A and B. Your relations are A to the fourth is E, B squared is E, that's from here. Okay, and BA equals AB. That was case 1.1. Okay, so that's the generators in your relations. That's the presentation of the group. Okay. Now you can also get this result from theorem 39. Go back, have a look at that theorem, and you may remember a group can be expressed in this sort of form. So Z, you take your factors, you take your prime, you take the order of your group, in this case it's 8, you express that 8 in terms of primes as a product of primes to integer powers. Now in this case 8 is 2 to the 2 times 2. That's one possibility. So so this is of the form z to the 4th times z to the 2, and they're isomorphic. These two are isomorphic. So that's another way, an alternative way of getting to this. All right. Okay. Now we do case 1.2. So case 1, remember b squared z, and the second part of that is when so you have these two possibilities here, right? When AB is now BA cubed. So for case 1.2, AB will be BA cubed. This second possibility here. All right. So if AB is BA cubed, then post multiply both sides by A here, here, and here. So you'll get ABA equals BA cubed A, BA cubed A, which is BA to the 4th, but the order of the element A is 4, right? So BA to the 4th, which is E, so you're just left with B. Okay? So for this group, its relations will be A to the 4th is E, because the order of A is 4. Yeah, so that's an example of a thinker, right? Yeah. Maybe just getting old. Well, maybe early onset of Alzheimer's. Yeah. Okay, so A to the 4th is E. B squared is E, that's from here. All right? And we've just got that ABA equals B. ABA equals B. Aha! Does that ring a bell? We've met that before, right? That presentation is of a dihedral group, right? Which one? Well, we're talking about a group of order 8. What dihedral group has order 8? Well, D4, right? Remember, in general, if you have a dihedral group Dn, the order of that group is 2n. Okay? So the group is order 8, and this presentation we've seen before. Remember this ABA equals B? That should be familiar to you now. So this, in this case, the presentation is the same as D4. So that means the group G8 with these properties, with this presentation, is isomorphic to the dihedral group, D4. Okay? Now, go to your text if you've got it. I didn't want to write, one, I didn't have space. I didn't want to write out yet another 64 entried group table, because I've written it out before in these lectures. So if you have the text, go to figure 13.3 for the table, for D4. Because we did a whole chapter on dihedral groups, so in the textbook, and in the lectures video, I wrote out D4, so that's already been done. Okay, so so we have another type for case 1.2, where your group, your G8, is isomorphic to D4. Okay, so how many have we got so far? So we've got the cyclic group, we've got that one, we've got this one, and now we've got this one. So this is our fourth type, fourth non-isomorphic group, and isomorphic relative to all the others. You know, all 4 types so far. All right, now. Okay, so we've done the 2 subcases for case 1. That's when b squared was e. Now we can go to case 2, where b squared is a squared. Right? And we'll find that it too splits up. Oh, that's an error. Should be case 2.2. Alright? Okay, so now we're in case 2, when b squared is a squared. Here. Now, watch. So a squared equals b squared. Now, a, you remember, is of order 4, because that's what we're doing here. Now, all this is part of here, starting here. So, b squared is a squared. Now, a squared has order 4, so a squared squared is a to the 4th, which is e, right? But a squared equals b squared, so we can put b squared here, so we get b to the 4th. So, so that means, this 4, that's the smallest integer that a can be the power of that gives you e. So that means b to the 4th, its order is 4. Right? So, so we have for this case, we now have 2 elements of, or at least 2, that have order 4. Right? So we've just shown that b has order 4. Now, similarly to several times, AB cannot be 1 of E or A squared or A cubed or B, right? We did that when talking about this. We did it talking where here. So we've already done it twice, and we're going to do it again, right? So AB cannot. We're talking about as again we're filling in the group table. So A B.